Hi, everyone. Thanks so much for being here today, and sorry about the delay. My name is Anurag Kadasne. I'm a senior PM at MongoDB working on the Atlas team. And I'm very excited to be here. The topic for today's talk is building for scale, how MongoDB Atlas grows with you. In today's presentation, we will talk about how you, as a developer, can start with a small-scale application on MongoDB and build it into a large-scale global application. Along the way, we will see how your business requirements change and how MongoDB Atlas can help you meet those business requirements. With that, let's get started. For the purposes of this conversation, let's assume that I am an independent developer who loves drinking coffee. In addition to liking coffee, I also like buying merchandise from my favorite coffee shop. I have a business idea. I want to create a website or a web application that allows my favorite coffee shop to sell its merchandise to consumers around the world. Now, because this is a hobby project, I have 4 key requirements from my database. Number 1, I want this database to be free to use, and that's because I do not know what the financial outcome of my project is going to be. Number 2, I want it to be provisioned in the cloud, and I want to make sure that it's provisioned in seconds, and that's because I want to get started quickly and deploy as soon as possible. Number 3, I want a flexible schema, and that's because I might know what the schema looks like today, but if my application grows, I want to be able to change the data schema quickly and efficiently. And number 4, I want the database to be scalable, so that if my application grows, my database grows with it. As you'll see in the next few slides, MongoDB Atlas is all of the above and much more. So this is how you would go about setting up a free tier cluster on MongoDB Atlas. You click on Create. You can select from any of the 3 major cloud providers. We allow you to deploy on over 120 regions. For the purposes of this use case, I've chosen AWS and US East 1. Next, we're asked to set up some basic security configurations, such as setting up an IP access allow list and a database user. And then you're asked to select how you want to connect to the database. You can do that using a driver in a language of your choice, MongoDB Atlas Compass, which is a web-based GUI to interface with your data, the MongoDB shell, or MongoDB for VS Code. In this example, I've used the Node.js driver. And in a few seconds, my free cluster is ready. Now, here are the key features of a free cluster. A free cluster comes with 512 megabytes of data and is throttled at 100 operations per second. It's configured as a 3-node replica set, which ensures high availability at all times. And lastly, you get great features of MongoDB Atlas, such as vector search, text search, change streams, as well as MongoDB charts that you can try before further investing into the Atlas ecosystem. I'm going to switch over to the demo. So now I have my backend that sits on MongoDB Atlas free tier. Because vibe coding is all the rage these days, I'm going to use Lovable to design a front end. Using a few prompts, I was able to come up with this landing page for an application called Coffee Merch Mart. And if I click on See Listings, you can see a few sample product listings. We have a product image, a title, a description, as well as a price. There's also an Add to Cart button. Now, tools like Lovable are not only good at producing beautiful front ends, they also help you interface with your backend, such as MongoDB Atlas. All I had to do was tell Lovable that I want to connect this application to a MongoDB Atlas free tier using the Node.js driver. And it was able to create this file where it had a dummy connection string. And all I had to do was replace this connection string with my connection string to connect the front end to my back end. We can go back to the slides now. Thank you. So I've created my front end using Lovable. I've connected it to my back end. This is what the schema looks like. We have 6 fields, which we will talk about in a later slide. And now that we have our application ready to go, we can move it into production. However, I am worried. The free tier's limitations are a bit low, and if my application were to do really well, the free tier would struggle to keep up with all of the requests. Therefore, I want a cluster tier that has higher storage, lower throttles, and is preferably pay-as-you-go, so that as my application grows, I'm okay paying a higher cost. To address this need, MongoDB Atlas has something that's known as the Flex tier. The Flex tier comes with 5 GB of data and is throttled at 500 operations per second. The pricing starts at $8 a month, and if your usage goes up, it caps out at $30 a month. Unlike other serverless offerings, you do not encounter any runaway bills because we cap our pricing at $30. The Flex tier also is configured as a 3-node replica set, ensuring high availability at all times. And it comes with features such as vector search, text search, chain streams, etc. So we've deployed the application to production. A few weeks go by, and the application is doing really well. The coffee shop that I've partnered with has started to make sales, and as a result, other coffee shops in the city have heard about my application. They now want to onboard their merchandise listings onto my application. So as you can see, our requirements went from being an application that serves the needs of one coffee shop to serving the needs of multiple coffee shops or multiple customers. How would that change my data schema? All I would have to do is add another field called shop, which represents the shop that the listing belongs to. Once I make that change, I can populate that field for all of my existing listings and populate that field for all of the future listings. Therefore, if you see the screen now, there's a little field that denotes the shop that the merchandise belongs to. There's a few from shops called Happy Coffee, and there's one from a shop called Moonbucks Coffee. If such a requirement were to have come up while using a relational database, I would have either had to alter the table, create a new foreign key, or create a new table and migrate the data. As you can see, there is friction between your business requirements and your code changes in relational tables, and that friction is greatly minimized when you use MongoDB. So now we've onboarded multiple coffee shops and multiple listings. My customers, which are the buyers of the merchandise, are having a hard time filter through the data and find listings that they really like. Therefore, I decide to implement a text search feature, and for that, I'm going to use MongoDB Atlas Text Search. MongoDB Atlas Text Search is a fully integrated text search solution powered by Apache Lucene. It allows support for phrases, terms, regular expressions, and wildcard searches. It is hosted within the same infrastructure as your operational data, which means you have very little management to do, and we handle all of the data syncing on your behalf. Let's talk about the advantages of using MongoDB Atlas Text Search. There are two key advantages that I want to talk about here. The first is you avoid the synchronization tax. Now, what is the synchronization tax? Let's assume you use MongoDB Atlas for your operational data, and then a third-party data store, such as Elastic, for your search data. Now, the first problem with this system is that you have 3 pieces of infrastructure to manage. You have the MongoDB Atlas piece, the third-party search data store, and a syncing mechanism in the middle that you would have to build. The next problem is you would have to make sure that your syncing mechanism is robust enough to handle the throughput requirements that your operational database has, which means that if there are a lot of writes to your operational database, if the syncing mechanism cannot keep up, your search data will face a lag, which leads to poor customer experience, which is what we want to avoid. If you were to use MongoDB Atlas, on the other hand, your operational data and your text search data is housed under the same infrastructure, and we handle all of the syncing for you. The second reason as to why MongoDB Atlas Text Search is a far superior developer experience is because you can use a single API, single unified API, to query both your operational data as well as your text search data. In a world where you were using Atlas for your operational data and another service for your text search data, your developers would have to learn 2 APIs, 2 query languages, which leads to operational overhead and reduces developer productivity. It is for these reasons that MongoDB Atlas Text Search is a far superior developer experience and product compared to using Atlas as your operational data store and a third-party search product as your search data store. Now, can I switch back to the demo, please? Now, our workload has grown, and the Flex cluster can no longer meet the demands of my workload. Therefore, I decide to upgrade to a dedicated cluster. How would I do that? All I would do is go into the UI, click on Edit Configuration, and select Dedicated. Now, a dedicated cluster has three major advantages compared to the Flex cluster. The first is it allows you to tweak your availability, which means that you can add additional nodes in different regions or on different cloud providers cloud providers. Excuse me. The second is it comes with world-class security and compliance features, such as bring your own key encryption, private networking, and the ability to edit backup configurations. The third is your performance is also tweakable, as you can select clusters with different RAMs, CPUs, or storage configurations. So when I'm here, you can see that we have a number of different tier configurations, all with different RAMs, storage, and CPUs. Here I've selected an M30 cluster, which comes with 8 GB of RAM, 40 GB of storage, and two virtual CPUs. You can tweak your storage by sliding the scale. I'm going to leave this at 40 GB. You can also provision your IOPS if you know exactly what your workload is going to look like. I'm going to leave that unchecked here. You can scale storage, which means that if you start running out of storage, Atlas will automatically increase the disk size for you without you having to do anything. And lastly, you can also enable cluster tier scaling, which I will talk about next. Can we go back to the slides, please? Thank you. So let's assume I have an M30 cluster. I have not turned on auto scaling, and I'm not paying attention to my infrastructure. One of the largest tech media publications publishes a great review about my application, and now there's a sudden spike in traffic to my application. Because of this, my database is going to be overwhelmed, which means that it won't have the resources to serve requests, which will lead to a poor customer experience and customers not being able to complete purchases. If, on the other hand, I had autoscaling enabled, autoscaling would continuously monitor my CPU and RAM resources, and if those were to go up above a certain threshold for a certain period of time, it would automatically scale me up to a higher tier, which means that my customers would not face any query latencies, which would lead to happier customers and more completed transactions on my application. Now, not only is autoscaling good at scaling cluster tiers up, it can also help you scale cluster tiers down. So let's say this spike after this article goes away. Autoscaling would detect that my cluster is drastically over-provisioned, and it would automatically scale you down to make sure that you, as a MongoDB developer, gets the best price performance at all times. Now, I've grown and built the application all by myself, and I obviously cannot keep growing this. There are new feature requests coming in, and there are new bugs that I have to squash every day. Therefore, I decide to hire a new team of engineers to help me out. Now, once I've hired this team, I want to make sure that they have the right authorizations to access Atlas and to access databases and clusters. In order to help with this, Atlas provides two types of role mechanisms. The first is an Atlas role, where you can define org roles and project roles that allows your users to either provision clusters, upscale clusters, add private networking, view billing, or even provide access to other Atlas users. The second type of role is a role at the database level, which you can think of as the data plane access, which allows your users to either have read or write access and access to other database functions at the database level. Once I have my team set up, they want to use IAC, or infrastructure as a code, to set up testing pipelines and CI/CD pipelines to make sure that my team is set up to accelerate developer velocity. And in order to help with this, MongoDB Atlas provides various IAC tools such as the admin API, Terraform, the Kubernetes operator, CLI, and CloudFormation that they can leverage. Now, once my team starts developing more quickly, I'm able to scale my application into multiple countries. As I expand into multiple countries, I realize that different countries have different data sovereignty, compliance, and security rules. And in order to help address those rules and requirements, MongoDB Atlas provides a lot of features. For the purposes of time, I can't go into every single feature right now, but let's talk about two of them. The first is private networking, which allows your application server to talk to your MongoDB Atlas database server using the cloud provider backbone, which means that your traffic is not exposed to the public internet. You can do this via using private endpoints or VPC peering. A second feature that is used as you expand into multiple geographies is the ability to modify backup policies. So with MongoDB Atlas, you can define how often you want to take a snapshot of your cluster, how long you want to store it for, and if our storage requirements do not make sense to you or do not comply to your requirements, you can move them into a separate cloud storage solution as well. Now, once we've grown the application to multiple countries, we start looking at usage data, and we see that a lot of customers are typing in queries such as, find me black coffee tumblers that help keep coffee hot. And this doesn't really return any useful results from text search. Therefore, these customers end up churning and leaving the platform. Now, in order to address this, I realized that customers want a feature that can help return results based on the underlying intent of that query. And such a feature is called vector search, which I'm sure you've heard all about today. Vector search enables similarity-based matching of objects, such as images, text, or embeddings, using vector representations rather than traditional filters or full text search. MongoDB Atlas comes built in with vector search. So in order for me to use vector search in my example, what I would do is I would run all of my listings through a vector embedding model, such as the one provided by Voyage AI. Those embeddings would be stored into MongoDB Atlas. Next, I would take a query such as the one I told you, run that through the same embedding model, and then run a similarity search between that embedding and all of the embeddings I have on Atlas. In doing so, I would return the embeddings of the products that are most similar to that query, which results in high-quality vector searches for my customers. Now, why use Atlas Vector Search? The reasons are very similar to the ones we spoke about for Atlas Text Search. The first is you avoid the synchronization tax because your text search data, your vector search data, and your operational data is housed within the same infrastructure, and we handle all of the syncing on your behalf. And the second is you can use the same set of unified APIs to query for your operational data, vector search data, as well as text search data. In fact, you can combine, you can have a single query that looks for all three types of data. So for example, if a customer says, find me espresso cups that are black in color and less than $10, I could first pass this query through vector search, which returns all espresso cups, all relevant espresso cups from my product listings page. I can then run a text search query and look for the word black, which filters for all black colored cups. And then I can run an operational search query where I filter for the price and return all cups that are black that are priced less than $10. In doing so, I can ensure that my customers get the best search results, which leads to higher conversions and more purchases on my platform. Now, once we launch the vector search feature, we see that most of our database resources are actually being consumed by the vector search feature because my customers love using it. That leads me to wonder, can I scale my operational workload separately from my search workload? The answer to that is yes. MongoDB Atlas allows you to have dedicated search nodes. When you deploy dedicated search nodes in your deployment, all of your text search and vector search queries are automatically routed to your dedicated search nodes, whereas all of the other queries go to your regular work nodes. These clusters can scale independently of each other so that you can make sure that you get the best price performance for your workload. Now, we've expanded our application to multiple countries, and availability starts becoming of prime importance. This is because we all have read about cloud provider region outages where applications have been down for long periods of time. And we want to make sure that we avoid that for our application. MongoDB Atlas dedicated clusters allows you to tweak availability. So the first thing that you can do is you can add more nodes to the same region, which would help reduce the workload, which will help reduce how busy the workload is on each node. But this doesn't really protect you against a region outage. To hedge against a region outage, what you could do is you can spin up additional nodes on additional regions within the same cloud provider, so that even if a region goes down completely, your application is still up and running. However, there have been very rare cases where multiple regions for the same cloud provider have gone down. In those cases, what you can do, or to hedge against such cases, what you could do is spin up additional nodes in a cloud provider region that is not your primary cloud provider. Now, there are other applications of this use case as well. So let's say you are a company that operates only on AWS, and tomorrow Azure releases an AI feature that you really want to try. Instead of figuring out how to go about moving all of your data from from AWS to Azure, what you could do is take your MongoDB Atlas cluster, which is currently in AWS, spin up a couple of read-only nodes on Azure, and then query those nodes directly, and your data is already in Azure. Now, so far, we've only talked about scaling vertically, which means increasing the RAM, CPU, and storage of our clusters. MongoDB Atlas also allows you to scale via sharding, which means that you take your data from your 3-node replica set or your cluster and then split it up into multiple clusters. These clusters could be in a single region or could be in multiple regions. In my case, because my application is global and my customers are all around the world, I would probably want a sharded cluster where all of the independent shards are sitting in different regions around the world to help reduce latency. In order to shard a cluster, all you need to do as a user is tell MongoDB what the sharding logic is, and MongoDB handles all of the moving of the data on your behalf. If for whatever reason you're not happy with the sharding logic, you can reshard by changing your logic, and MongoDB Atlas will move your data from one shard to another without any downtime. Lastly, we also released a feature called independent shard scaling, in which you can scale your shards independently of one another, so that if you have, let's say you have some shards that are in M30 and you have a certain shard that's running really hot, you could scale it up to an M40 or an M50 to make sure that you get the best price performance for your deployment. So in summary, MongoDB Atlas grows with your application from a free tier to a replica set to a sharded cluster, ensuring the best price performance at every stage. You can easily add features like search and vector search with a consistent developer experience to make sure that your customers are getting what they want at every stage of the product development lifecycle. Lastly, you can streamline database management with robust IAC tools and IAM tools that MongoDB Atlas provides out of the box. Thank you so much. With that, I'd like to introduce Sheldon DSouza. He co-leads the investment products technology team at iCapital, and he's responsible for defining the technological backbone of the alternatives and the insurance platform. Please give a round of applause to Sheldon.
Thank you, Anurag. Hi, everybody. My name is Sheldon DSouza, and I co-lead investment products technology at iCapital. Let's start with a little story. iCapital was founded in 2013 with the goal of democratizing access to high-quality alternative investments to our wealth managers and their clients. The alternative space is a very fragmented space, and let me take a step back and talk to you about what an alternative investment it is. It is a class of investments that sits outside of the scope of traditional investments such as stocks, bonds, equities, etc. It was a very fragmented space in 2013, and one of the founding tenets at iCapital was to create cohesion in this space and through innovation and architecture. So as part of this, we deployed the Document Center in 2018. The iCapital Document Center was supposed to be a unified experience for all our clients to access their investment-related documents in one place. It was easy for all the producers of these documents to send it to one place, that is iCapital, and all our clients could log in and access this information. Given that it was getting data from multiple sources in a fragmented environment, we were able to create cohesion here and create something that everybody appreciated. When it was first launched in 2018, in 2019, we had our first full load of ingestion of data, of documents on the platform. That was 80,000 documents. In 2025, we are poised to load 12.5 million documents on the platform. That represents a 60% year-over-year growth. And at this time, as of the 1st of September, actually, we manage in excess of 30 million documents on behalf of our clients. So this is a fantastic platform that is really appreciated by our clients. But let's take a look under the hood and look at the data behind the scenes. So when we built the application, we built it on a relational database, Postgres, with a Ruby on Rails application stack sitting on top of that. Whenever we added data from a new integration provider, we would create a new table to hold that information. Whenever we added a new class of documents, we would add a new table. The document center was supposed to be a unified experience. So essentially, we had to take data from all of these tables and present it to the user in one unified view. That meant a complex and costly join, which resulted in poor performance. We tried to alleviate that by adding an Elasticsearch layer. So we would compute a unified view and push it to Elasticsearch. However, the push was periodic. It was not real time. So we couldn't send real-time insights and information to our partners. This was not the experience we wanted for them. Besides that, since the database was horizontally scaled, every time we had to do DB migrations, there was a worry if the migration ran through all the tables or not. This resulted in downtime. We became very conservative in deploying new features. The business logic was tightly coupled with the database. There was complex logic overall. So at this point, what we had was a document center that served our clients' needs. It was scaling up, but not very well. It was delivering, but there were pain points. So as we thought about how iCapital will grow over the next decade or so, we decided to pause and reflect and see how we could re-architect this platform. So enter MongoDB Atlas with Scala microservices. Since MongoDB is optimized for compute, not storage, you can focus on your data model rather than worry about how it is stored in your database. This allows you to be thoughtful about your data models and build something that works perfectly for your use case. It also offers 4 things right out of the bat that are fantastic. The first one is security, scaling, performance monitoring, and alerts. These are a must-haves for any enterprise-level application. Besides that, there were a lot of good-to-haves, such as auto version updates, change stream processing that let us push real-time changes to our clients, online archive, which allows us to archive our data, keeping only the data that we want in memory. And besides that, iCapital acquired a company in 2023, which brought a lot of institutional knowledge about MongoDB Atlas to iCapital. So we had a team of engineers who knew how to use Atlas. We had a use case that was perfectly tailored for the platform, and we were confident that we had a good design to go with it. So with this, we were able to build a next generation stack that is now ready to meet the evolving needs of our client and scale up to the complexity of the business. Since we are now modular, we are able to independently deploy services, react to specific market events, and target those specific services for upgrades without full system redeployments, which means that the application is always available to our clients. Scaling is also achieved by scaling those specific nodes that need resources during bursty periods. So we don't have to worry about scaling up the entire application. The application performs exactly as it should, with some parts being scaled up during when it needs and the other parts not. Since it was now modular, we were able to build or work with our partners to understand their specific use cases and their specific personas and build custom-tailored solutions for all of them. And these are, so what we have is now a document center, but we can keep scaling out apps which meet whatever requirements our end users want. So at this point, you might be wondering, that's a great story. What does it take to move from a relational to a non-relational database? So the first, and this is something that we have learned over as experience, so I'm happy to talk about this later. The first thing is essentially stop thinking in a table-based mindset and start thinking in terms of collections and documents. MongoDB is document-centric, so you want to spend time building that data model and getting it right. It offers a lot of flexibility, so you want to be able to leverage that flexibility to get what is right for you. The second thing is plan your migration early on. Figure out how you will migrate the data, whether you will migrate it by client, whether you'll migrate it by asset class, or a combination of any of these. But having that process ready, tested, and idempotent, so you can just run the migration constantly and ensure that the data is always steady in Mongo, ensures that you do not miss anything when you go live. The third thing is aggregation pipelines. The power of Mongo comes through its aggregation pipeline system. However, it's a different mindset from thinking in terms of classic SQL queries. So you need to start thinking about how you would use aggregation pipelines. You need to embrace denormalization, and you need to also think about how you optimize your pipelines, because over-optimization can also burn you. The last thing is get comfortable with the Atlas console. The Atlas console is your one-stop shop for everything that you need in your MongoDB platform for performance tuning as well as troubleshooting. When that production issue hits, you need to be able to jump into the right place on the console and start looking at insights in order to help you react to that issue. Finally, plan for sharding and archival. Anurag mentioned sharding just recently. Sharding is something that you should think about on day one. Archival is something that you should think about on day one. And there's no reason not to. These are offered to you out of the box on the Atlas platform. It allows you to think about how you will have only relevant data in your database and nothing else. Sharding also you can always reshard, or you can switch your shards. Not that I would advise you to do that, especially with a lot of production data, but it is possible with minimal downtime. But getting that sharding strategy right when you have a small set of data is always a good idea. And you don't have to start thinking about this when your data grows and becomes unmanageable. So I thank you, everybody, for your time and attention. Appreciate your presence. If you have any questions, you can reach out to us. We will be around in the crowd. Bye-bye.